Welcome to Hartman Math. Today we're going to look at linear equations. We're going to start prior to that with a warm-up where we have an equation and you're going to choose which of these are solutions of that equation. There might be more than one answer, so definitely check them all. Go ahead and pause the video here and choose your solutions. All right, so we're going to check -5 first, and if we're just going to determine whether a value is a solution to the equation, we're going to substitute into the equation the -5 for x here and here. So -5 squared is 25 minus 6. Does that equal the -5 that we're substituting in? Clearly it does not, so that's not going to be a solution. Let's try the -2. -2 squared is +4 minus 6. Does that equal the -2? Well, 4 minus 6 does equal -2, so that one does work. So we're going to choose that as a solution. How about 1? 1 squared minus 6. Does that equal 1? Apparently not. It looks like -5. Does that equal 1? No. So let's try 3. 3 squared, 9 minus 6. Does that equal 3? It does, so we're going to choose that to be a solution. All right, so our title today is Linear Equations. It is 1.1. We're going to begin with example number 1. 5 minus 7x equals 20. The rules to solving, in this case a two-step equation, are going to be, number 1, eliminate any parentheses if they are in the problem. We do not have that situation here, so we don't have to worry about that one. Next, combine any like terms, and we're talking about left of the equal sign or right of the equal sign. Any like terms, like for left, is there a 2y and a -7y? Those would be like terms. We don't have that either in this case, so no like terms to combine. And then we're going to undo by doing the opposite. So we want to solve for x over here. We want to get that by itself. So we're going to undo the other stuff by doing the opposite. We typically want to start the farthest away from our variable. So we are going to want to get rid of this 5 first. So to do the opposite of 5, we're going to go -5 on both sides. So that's going to be our first step. We generally do want to start with addition or subtraction most of the time. So we're going to subtract 5 from both sides. Careful with your negative signs. The negative in front of the 7x is going to come down as these do cancel. And on the right, we do get 15. So we undid the addition or subtraction. Next is typically going to be to undo multiplication or division. Right here we do have multiplication. So we want to get rid of the -7. We're going to want to divide by -7 on both sides. That would be the next step. So -7 divided by -7 becomes 1. So this essentially becomes 1x, which we would just write as x. Now on the right, the way that we want to correctly write this is to say that a positive divided by a negative is a negative. So the negative is not going to stay as part of the denominator. It's going to come out in front of that fraction. And I don't think that 7 is going to evenly divide into 15. So it's okay to leave it as a fraction. X equals -15 over 7. That would be our solution. All right, you try, so go ahead and pause the video here. Go ahead and solve for x. Hopefully, if you've done this correctly, which would be to subtract 2 on both sides first, and then divide both sides by 11, you would have gotten x equals 31 over 11. If you didn't get that, you may want to try to go back and rework it now. Example number 2, the same rules are going to apply. Remember, back when we had listed the rules, at the top there was going to be to remove the parentheses. We do that via the distributive property. So we're going to look at what's in front of the parentheses. And in this case, it's negative 2. The 5 really doesn't belong there. We don't want to violate the order of operations by doing subtraction, and then the distributive property involves multiplication. We want to do the multiplication first. So we're going to distribute the 2. It does have a negative, so we want to think of that as negative 2. The sign in front always matters. So I'm going to just kind of highlight, or in this case circle, what I'm going to distribute, which is the negative 2. I'm going to show with arrows that it's going to multiply into each of the terms in the parentheses. Right there. So the 5 stays. We get negative 2 times 4x, negative 8x. Negative 2 times positive 3 is going to be negative 6. The next thing on our rules was to combine like terms. Remember, think of here as the divider. Can I do anything on the left? Can I do anything on the right? And I think in this case we can do some simplifying of like terms, combining of like terms on the left as the 5 and the negative 6. They are like terms. So if we identify those are our like terms. Let's combine them. What is 5 combined with negative 6, or 5 minus 6? We would get negative 1. I've put that behind the negative 8x. It does not really matter. You could put the negative 1 in front of the negative 8x, but I typically do like to have my x's occur before constants. So we've gone through that. Now it's just a matter of undo by doing the opposite, kind of as far away from the x as possible. Undo the addition or subtraction. Let's undo the subtraction of the minus 1. We're going to add 1 to both sides. Careful with your signs over here. It's a negative 3. A positive 1, 3 negatives and 1 positive. It's going to make a total of 2 negatives, or negative 2. And then we're going to want to get the x by itself. Keep focusing on the left where the x is. Get rid of the negative 8 by division. We're going to divide both sides by negative 8. Over here, we're going to get x equals, as the negative 8 divided by negative 8 essentially cancels because it is 1. And on the right, we have a negative divided by a negative is a positive. Be careful here, because it's 2 divided by 8. We don't want to make the mistake of, well, I'll just do 8 divided by 2, because it's 2 divided by 8. So anytime that the numerator is smaller than the denominator, we are going to get a fraction. So we've got to think of just reducing what evenly divides into both of these. And that's 2. So we're going to divide top and bottom by 2 after making this a positive. We do get positive 1/4. You try on this one here, pause the video here, see if you can work out and solve. And hopefully you have gotten that x equals 2, where the critical and most important step is distributing the positive 4 to get positive 8x minus 20, and then combine the x's from there. You didn't get x equals 2, go ahead and try that strategy at this time until you get the x equals 2. Example number 3, no parentheses, no like terms. So we'll go about solving, but this time we do have variables on both sides. So one thing to kind of consider when there are variables and or numbers on both sides, you may want to eliminate the smaller variable first. And when I say smaller, I'm really talking about farther left on the number line, where we've got negatives over here and positives over here. So in this case, negatives are always going to be smaller than positives. So I would want to eliminate this first. And it's always probably best to eliminate x's or variables first. So to get rid of the minus 3x, let's go plus 3x on both sides. And I am going to line that up here and here, because those are our like terms. So over on the left, 2x plus 3x, we have 5x when we combine our like terms. So if we've dedicated getting x's on the left in this case, then that is going to mean we're going to want to get the numbers on the right. So we're going to solve for x. We're going to get rid of the plus 11. So subtract 11 on both sides. We're going to get 5x equals a negative 4 and a negative 11 do make negative 15. Now we're going to undo the 5 now to get the x by itself. We'll divide both sides by 5. And we do get x equals negative 3. And remember, if it is important to know if you got it right, the nice thing about linear equations, and really all equations, is they're very checkable. So we can substitute this back in to see if we got this right. So 2 times -3 is -6, plus 11 is 5. Does that equal? Let's check it out over here. -3 times -3 is 9. -4 is also 5. 5 equals 5, true. So if you know it's true, then you know that that definitely is a solution. If it wasn't, you might just want to look back and see, did you make a mistake somewhere? Oftentimes it might be something as simple as a sign mistake. A positive where it's supposed to be a negative, vice versa. All right, one for you to try here. Go ahead and pause here, work through it. All right, before I show the answer here, you're going to probably want to go -3x on both sides. You really don't want to eliminate one side entirely. So although it is legal to subtract a 7x on both sides, we don't really want to wipe out one side, because then it gets unsure of what we should do. And a lot of students will move the equal sign, creating a problem. So if we don't want to wipe out a side, we definitely would want to go -3x both sides and go from there, and we would get x equals negative. Notice the negative out in front there, the fraction 5/4, and that is fully reduced, and it's okay to have a fraction that is essentially more than 1, or an improper fraction. All right, final example today. We have a word problem here. 3 more than twice an integer is 21. What is the integer? So here are going to be our class rules for solving word problems. It has to be done with these steps. First and foremost, number 1, you need to have a let statement. And the let statement is going to define your variable or variables. What is unknown in the problem? What letter are you choosing to represent that? So the question is, well, what's the integer? So pick a letter that's going to be a variable to represent that. We could say let x equal the integer, or n equal the integer, whatever your choice is. We need to have that let statement. You must have that let statement before you get into writing the equation and solve it, because that would be the next thing. Step 2, write the equation, but do so slowly. A lot of students get flustered by trying to do the whole thing and seeing the whole sentence or paragraph or whatever all at once, and you just need to break it into chunks. So we're going to read a little bit at a time. 3 more than, that's kind of that first part. 3 more than, and that's going to indicate addition. But remember, in the order of operations, addition doesn't usually come first. So we're just going to pause on that, hold off on that, keep reading and see if there's anything else going on. Like the next part says twice an integer. Twice means 2 times, so that's going to indicate multiplication. That would come first. What's our integer? Well, we just said that it was x, or maybe you had said that it was n or q or whatever. So we're going to say 2 times x, and we could just write that as 2x. All right, what comes next in reading is, and is the barrier here. Is the equal sign here, so we can finish off what's left by going back to this. 3 more than doesn't really mean 3 plus, it means to add 3. So we're going to go plus 3 instead of 3 plus. Now if you had written 3 plus 2x, it would mean the same thing. However, if this had said less than, it doesn't mean the same thing. So let's just be consistent and always do it correctly. Multiplication part first, followed by the addition or subtraction. Equals 21. And there's our equation. So you're going to get credit for different parts of this. All right, number 3, solve. All right, let's solve our equation. We want to get x by itself. Let's undo the addition. Subtract 3 on both sides. 2x equals 18. Undo the multiplication. Let's divide both sides by 2. We get x equals 9. Now most of the time I'm going to box my answer. Notice I'm not boxing this because this is not the answer, because it was a word problem. So we want to answer the word problem in a fairly concise sentence. Question was, what is the integer? The integer is 9. So part 4, write the answer in a sentence. The integer is 9, period. Box your answer. That's it for today. We'll see you next time.